Hello, my name is Srinivas Shekar. I am CEO of Pantherun Technologies, headquartered in India. I'm very happy to be part of TechNadu's Humans in Cyber video interview series. Thank you for including me here. Let's dive a little bit into the subject. Pantherun is a cybersecurity innovator. We build encryption technologies to allow for data protection to happen across networks, across devices. So we're trying to decentralize how encryption happens and allow it to flow everywhere across a network. Today, when you look at networks, data available with us says that less than 1% of data on a network has any form of protection. And this is going to be a very big problem going forward. It's already, there are way many attacks happening which take advantage of the lack of data protection. The industry standard for encryption today is a standard called AES. It's considered a very difficult encryption approach to break. Without a key, it takes over 100 man-years of effort to break the encryption. AES depends on a key. A key is required to encrypt data, and the exact same key is required at the destination to decrypt data. Without this key, it's almost impossible to break the encryption. Unfortunately, current implementations of AES depend on an exchange of data, exchange of keys. Yeah, so keys initially exchanged across the open network, and then a derivative of this key is used to encrypt and decrypt. So what this means is that anybody listening for the key will have access to will get access to the key, and hackers sitting on networks can access this key at any time. So what has Pantherun done? Pantherun has generated an approach, a patented approach, wherein we use a machine language algorithm to generate keys from past data. Yeah. So this key is generated in real time. Yeah. The next packet is encrypted with this key. Yeah. When the packet reaches the destination, the ML algorithm runs on past data at the destination, generates the key to decrypt the packet. So in this way, we've eliminated the need for exchange of keys. A key is dynamically generated at both ends without the need for an exchange. This makes our encryption approach significantly safer compared to any other AES approach that exists today. Let's look at, since we use AI or ML, let's look at the impact of AI on cybersecurity. AI plays a big role in data protection. Like I showed you, we use it to generate keys. AI can also be used in many applications to determine what data to encrypt and what data to allow in plain text. AI is also used, in addition to data security, it's used in other forms of cybersecurity, where AI can be used to detect and prevent intrusions by hackers into networks. It can be used to find patterns within the network and find where there are vulnerabilities where a hacker may decide to attack. So AI has many uses in data protection as well as in cybersecurity in general. Yeah. Now let's look at quantum computers, and how we protect against quantum attacks. Quantum computer is a very capable computer that can process large amounts of mathematical data in a matter of few seconds. So it's set to revolutionize how we will process large amounts of data. But it also can threaten AES-based encryption, which is extremely maths-oriented. The way it is estimated that a quantum computer will be able to break AES within a matter of a few seconds, because it will look for inputs from the AES encryption that is happening. So first input that will get is the key exchange. Yeah. So as a key is exchanged, if it captures the key, that acts as the first input. Second input is it looks for data. The current encryption approaches change data format as they do encrypt. So encrypted data looks very different from the unencrypted data, and gives a lot of inputs on what kind of encryption is used. So these are inputs that the quantum computer will use, yeah, and be able to crack the AES based encryption. So therein we play a big part, because with our implementation of AES, we've eliminated the key exchange. So the first input to the quantum computer is gone. Yeah, the second input, which is data format change, as encryption happens, is also being eliminated by us. So in our case, encrypted data and unencrypted data look exactly the same. Yeah. So what this means is that a quantum computer used by a hacker who's listening in will not get any inputs on what kind of encryption is being used. So thus it nullifies the impact of a quantum computer. That is how our technique is considered to be quantum safe by all the peers and universities that have evaluated us. Let's look at the value of real-time encryption now. Yeah, we are truly a latency-free form of encryption. We are able to encrypt and decrypt data without adding any delays, up to speeds as high as 100 gigabits per second. So we are ideally suited both to work on edge devices, which could be cameras, sensors, and so on, or also on the cloud. Yeah, so we are truly an end-to-end implementation of AES without any delays. Now, why is this critical? Let's look at, critical applications like defense, industrial, automotive, and so on. All of these require split-second analysis of data and decision making. So if you cannot provide encryption on these kinds of applications without delays, yeah, they will not be able to accept that form of encryption. So we are ideally tailored to fit into these kinds of mission critical infrastructure where you require real-time analysis of data. Thus, our encryption approach, which doesn't add any delays, is critical to these kinds of applications. Defense has extensive applications where you need this kind of mission critical response times, which we are able to cater to with our defense customers. Let's look at what kind of attacks happen in these kinds of defense establishments. We have seen a lot of attacks like denial of service attacks, where the whole network is clogged and data is not delivered. Yeah, this is one kind of attack. Another kind of attack is where wireless networks are broken into. Yeah, and man in the middle type of attacks happen, wherein data is waylaid and a different data is passed on to the destination. You also see attacks on drones, which are critical today to our defense infrastructures. You see attacks on radio communication as well, that's waylaid. So these are all the various kinds of attacks that happen on defense and critical infrastructure. Let's also now look at building deep tech in India. Yeah. Deep tech has really come a long way over the last 8 to 10 years. It is used to be difficult to build out of India, used to be difficult to get recognition for deep tech companies out of India. Yeah. But that is changing now. We are acknowledged as an engineering powerhouse. Yeah, and we are able to build out deep tech companies well now. Yeah, the engineering quality is very, very good in India. Our government is also supporting us a lot. yeah, with timely investments and a lot of attention to this area. So I think India will progressively become a deep tech powerhouse, providing solutions globally. Quality is very important, and that's something that we need to focus on as we build our unique solutions in the deep tech area. Thank you so much. I'm always available for any questions or any follow-ups. Yeah, yeah. And it's been wonderful to be part of this program. Thank you.